Good. Then welcome everybody to my lightning talk. I haven't prepared much slides yet, except the one about me. So don't know what your expectation is from the lightning talk. I'm sorry. I stole this slide basically from the talk I gave at the OWASP conference in London. I came just from the OWASP conference. I'm located in Germany, Hamburg, and I do consulting, like pen testing for system, network, and application security. Training, everything. I'm also an open source guy since a long time before. Well, the term open source was there. I compiled NSCA browser and NSCA web server. Who knows it? The product. Okay, you. on Unix workstations, before I basically took floppy disks with me at home, where I copied Linux distribution from. Okay, short history. This product now, a project, TestSSL.sh, there's a website which is similar, and it's also the name of the tool. It's now pretty mature, I think, and it started as an in-house project, basically for pen testing, to test the TSL, SSL status or posture from clients for server protocols, and it was ciphers and so on and so forth. And I got it extended, and at a certain point I thought, okay, let's just release it, and then after a few shortcuts, it ended up at GitHub. So that was like, I don't know, 2.5 years ago, like that, and basically it took off. I got a lot of distributions. So the rest of the talk I would like just to do some demos, but I don't know who knows the tool. Okay, not very much. Okay, then I explain shortly what the tool does. Basically, the tool is there for testing the encryption of every server out there in the internet or also in your local network. This could be a web server, this could be IMAP server, this could be a POP server, this could be a Java server, this could be a MySQL server, which with some patches also speaks SSL encrypted. This could be a PostgreSQL server. This could be basically anything. Okay. Just a few. I'm just demoing it. Probably that would be the best, so that you get an idea what the tool is like. So first you see a banner. Everybody seeing that? Or do you want me to make it a little bit bigger? Okay. Okay, let me just, don't know why localhost doesn't work now. Anyway, need for the remaining stuff in network. Good thing. Localhost, okay. Reading name servers. Okay. Okay. Okay, now it starts. Good, this is an Nginx server I'm running now. And let it do the checks and then explain why it's doing it. I can also explain. Okay, first of all, you see that's trying. This is the error. It's trying to look up to do a DNS lookup. It failed because I didn't configure the network correctly. Then it tries to determine the service. Unfortunately, it didn't because this is a plain web server and I didn't have any web pages behind it. So it didn't detect that there's an HTTP server behind it. It also, let me just, let's just do it again because the picture was a little bit messed up. Now it's a little bit better. It does all the protocols, tests for SSL, V2, V3, test TLS 1 through TLS 1.3. I get later into that a little bit more. It tests also NPN, which is SPDY protocols. It tests HTTP2, which is LPN protocols. Then it tests certain group of ciphers, for example, anonymous ciphers, where where the server side is not authenticated. To me, same as anonymous ciphers. Tests the old export ciphers, which were legally required, but on some servers still available. Well, legally required like 15 years ago. I don't know whether it was also in the UK. At least it was in France somewhere, and in the US. Okay, then it also tests, of course, very, very strong encrypted ciphers. This gives you an idea of the posture, how your status looks like. The one thing which you might notice that there are different colors here in the output, which also tells you what is really good and what could be bad. To the bad things I'm coming. The good things are in light green, which says it's very important that this thing is good. This is good, but this is a little bit lower than the other green. Then next section, for example, tests the perfect forward secrecy ciphers and the curves, if there are any curves. On this server are a couple of curves, as you can see over there. Then it tries just with what I'm offering, do a client hello. It returns then with a response, and it gives TLS v 1.2, which is okay. One important thing, which, for example, which is often forgotten, is the cipher order. Normally, a SSL or TLS handshake works that a client is sending some ciphers in a specific order, specific to the client, and the server side then picks the server which matches both. But there are different scenarios from the server side. Either the server determines the best cipher which fits for him, or it just takes the first cipher from the client, which is bad, which could be a bad cipher. So it's important, for example, that the cipher order is correct, which a lot of people just forget. Oh, what is that? So let's go a little bit down. You see that things are getting bad, a little bit, or worse. Let's put it that way. You see that, I'm sorry about the gibberish here. Seems to be a problem with the screen currently. I do not understand. That the certificate which is there has a SHA-1 signature algorithm. Of course, it's self-signed. You also see that here's a couple of complaints. This is a testing of the server defaults, which is mostly related to the server certificate, whether there's trust from which the certificate is issued, whether the chain of trust is okay, for how long the certificate is valid, and other stuff. You see a lot of red stuff here, which also gives you, on the first glance, the idea what is wrong. Then comes the vulnerability section. Well, as it's a relatively new system, there are no vulnerabilities. I don't know whether I have to go through each vulnerability. There are certain, this is the recent one, for example, Robert, return of the Bleichenbacher Oracle attack. which happens on servers which use RSA key transport encryption, which also made it into the project, and several old vulnerabilities. And you get a listing of ciphers which are generally supported. There's only a handful of ciphers, 1, 2, 3, 4, 5, 6. Well, one more than a handful of ciphers. And basically that's it. At the end, you see a client simulation, which doesn't work here because there is no really HTTP web page there, just for the server. So it just does a handshake with a client simulation from Java 6 to Java 9, and then with OpenSSL. It looks a little bit different, for example. I'm now extending that a bit. I have a cheat sheet here. So, what to do next? Let's do this one. So I have basically two websites. One website basically is a proxy front end, which is hosted at Cloudflare, which is the .NET domain. Now it takes all the IP. It resolves both IPv4 IP. I can also run Ipv6 checks, and does a whole check again. Here, for example, you also see that TLS 1.3 is offered with draft 28 and with draft 23. And it does that, well, over and over. The network seems not to be very fast because I'm using my mobile here. So it'll take a while. Well, as it is hosted now at Cloudflare, the settings should be quite fine. So there should be no red there. Let me just do something. So also see the certificate output from TestSSL.net is of course a little bit more interesting because it also passes the certificate, and Cloudflare issues a certificate not per customer unless you pay a huge amount or a little bit more amounts for it. I'm basically using the free version from Cloudflare here. So you see a couple of domains which are also in the certificate, which is used for my website. You also see, don't know whether you listened to the talk from Mark Goodwin. You also see certificate verification list, OCSP URI, which are here in the certificate. You see that OSP stapling is supported, for example. Certificate transparency is supported, and the CA records from DNS are queried. So, yeah, I could go on further with the demo. I have a few things prepared, but let's do it in an interactive way. Do you have any question? Or do you want to see anything?
Is this latest version that's on build right now with TLS 1.3? Or is this like private one that you've got?
Say it again?
Is this version of TestSSL a private one that you've got, or is this the current latest version?
This is the current latest version, yeah. There's one bug I fixed. I need to check in again. The TLS 1.3, well, at GitHub, there's the branch 2.9.5, which is the so-called stable branch, right? And there's a 2.9.dev branch, which is now becoming stable. As the banner says, it's better. It's better, but I will soon rename it to release candidate. Because there are a few bugs still in GitHub, which known bugs, which need to be fixed. Of course, every software has bugs, but then it's going to be at a certain point released, that version. And but in 2.9.5, Actually, I don't know whether TLS 1. I think TLS 1.3 is not supported in 2.9.5, but in 3.0 it will be supported, of course. And of course, the thing with TLS 1.3, there are several drafts, and there's a final. It's was also kind of difficult to test, because you have to test basically for every draft, and send a client hello there, and then look at the response. And also provide different extensions, TLS extensions. So anything else? Okay, surprise, surprise. Then I do some maybe more interesting stuff. Of course, yeah, let's do this way. We are all, well, while the test is running, I can also speak. Let's say, encryption ecosphere is really weird currently, in my opinion, because we are focusing heavily on encryption for web traffic, HTTP. But what we often forget is that there are also other protocols around there which people use. Mainly IMAP, POP, SMTP. Something which the tool cannot do is, for example, zip or streaming protocols. That's on the agenda. So everything else basically is either not encrypted in the internet or is encrypted just by coincidence. So one thing which is well used with StarTLS, for example, this is opportunistic encryption. Basically, it sends first on the application layer a handshake in clear text to the server side saying okay, show me what you got. And if the banner says okay, StarTLS is supported, then the client can say okay, I continue with encrypted communication, and off you go. So here, for example, you see from a German provider one-on-one the posture of the IMAP service, which is still available as StarTLS service, which uses opportunistic encryption. That means an attacker can do man in the middle. For example, depends on the client, of course. If you tell the client you have to use encryption, then the client, and if the server says, or in the man in the middle says, okay, I do not offering encryption, then it depends on the client whether he continues the conversation in clear text or whether just shuts everything down. This is also for SMTP the case. There are also, of course, different ports. This is now for StarTLS. Of course, you can, I think 993 TIMAP means use StarTLS. This would be the encrypted port, where you can speak clear text here. So just that is just the basic run. Okay, good. If you invoke it without any arguments, as you can see, a lot of options. I just displayed, or almost displayed, only the default run so far. I explained the several sections, but you also can customize it to your needs. So if you only want to see the protocols, you just use -p or -- protocol for each. Almost every option, you have a short option and a long option. Since I'm lazy, I'm a lazy guy. Am I done?
Yeah,
okay, good. Good. Final words or final questions, maybe? Anything else? Okay, it's free at GitHub. You can just have a look or look at the website TestSSL.sh. There's also a pointer to GitHub. I'm also here for questions if you want to, and use the tool. It's free. It doesn't cost anything. Okay, thank you.